Hi everyone. In this lesson, we will talking about acceleration. But before, let us compare between velocity and acceleration. What is the difference between velocity and acceleration? Velocity tells you how object position is changing with respect with time. How object position is changing with time. So V equals displacement over time. Displacement, which is a change in position, or equals delta x, change in position, over elapsed time, equals x final position, minus x naught, initial position, divided by time. This is the velocity. Let us take an example. V, say, equals 5 meters per second. What does it mean? It means that the distance, the object's distance, it changes, increases 5 meters each second. The distance increases 5 meters each second. Let us make table t and x, the position of the object. At t equals 0, let x equals 0. After 1 second, since the velocity is 5, it will move 5 meters. The object moves 5 meters. After 2 seconds, it will be 10 meters. After 3 seconds, it will be 15. So the object distance, it changes each second by 5 meters. This is the meaning of velocity. Now, what is the acceleration? Acceleration tells you what is the object velocity, it changing with respect to time. What fast object velocity, it changes with time. A equals delta V, a change in velocity, over delta T, time elapsed, equals V final velocity, minus V naught, initial velocity, over T, elapsed time. So acceleration tells you how fast object velocity, it changes with respect to time. For example, if A equals 5 meters per second squared, what does it mean? What does this mean? It means that each second the object velocity, it changes, increases by 5 meters per second. Each second the velocity increases 5 meters per second. Since A is positive, so the velocity will increases. If A, for example, equals minus 5 meters per second squared, this means that the velocity decreases. If we make a table for this time and V, at t equals 0, let V equals 0. Start from rest. After 1 second, the velocity will increase. For this case, will increase to 5 meters per second. After 2 seconds, it will be 10 meters per second. velocity changes, but by an equal amount. It changes by an equal amount each second. This is what is we called constant acceleration. Constant acceleration. The acceleration here is constant. Does it change? Does not it change with time? Does not it change with time? Constant for all journey of the object. But if we say A equals, for example, 5t plus 4, this is not a constant acceleration. This is a changing acceleration. It changes with time. As time changes, A also it changes. Okay? But for a constant acceleration, A is just a number. A equals A equals maybe 5 meters per second square. This is a constant acceleration. Okay? Let us try to draw the relation, the time velocity curve in the case of a constant acceleration. Put t in the x-axis by second, measured by second, and v in the y-axis measured by meters per second. From this table, for this example, t equals 1, 2, 3, 4, v 5, 10, for 3 will be 15, increases as we said, 5 meters per second each second. V will be 5, 10, 15, and so on. For t equals 1, v will be 5, 1, 5, here. 2, 10, 2 and 10, here. 3, t equals 3 and 15, 3, 15, here. If we join these points, we will have a straight line. So the velocity time curve for a constant acceleration is a straight line. What is the slope of this curve? What is the slope of this line? To calculate the slope, we take any 2 points in the line. Any 2 points. The results will be the same. For example, take this point and this point. The slope equals delta y over delta x. Delta y here is v, delta v. Delta v is 15 minus 5. 15 minus 5 over delta x here is delta t, change in time. 3 minus 1. 3 minus 1. It equals 10 over 2 and results in 5 meters per second squared. So the slope here is the acceleration, is the constant acceleration. Okay. Now, if we wanted to draw the acceleration time graph, what we will say, what will we have? Now A is constant for each time. For t equals 1, A will equals 5. 5 here. For t equals 2, A also will be 5. For t equals 3, A also will be 5. So we will have a straight line parallel to x-axis. since A here is constant, has a one value for all the motion of the object. Okay. If we wanted to draw a position time curve also for a constant acceleration moving, for a constant acceleration moving, what we will have? For each second, the velocity will increase. For each second, the velocity will increase, as so in the table. 5, then 10, then 15, and so on. As the velocity increases, the distance traveled by the object also increase. So the relation here will be like this, increasing. Okay? This is for a constant acceleration. Now, let us compare between the moving motion with constant acceleration and constant velocity. If the particle moving with constant velocity, it means what? It means that A is 0, no acceleration here, because the velocity is constant. Okay, let us draw the curves, the three curves for the constant velocity, as we draw it for the constant acceleration. Let we start with xt curve, position time curve. Time in seconds and position x in meters. What we find here, let we take the example v equals 5 meter per second. V here is constant, doesn't change for all the trip. So the object will travel same distance in same times. The relation will be like this, straight line, straight line. The slope of this curve will be equals v, the velocity, the constant velocity. Okay, the velocity time curve in this case will be like this. V is constant, so will be a line parallel to the x-axis. Here V is constant. And A will be 0. The acceleration will be 0. For the acceleration time curve, the curve will be straight line along x-axis. Since A here is A is equals 0. A is equal 0. This is the three graphs for a constant velocity, and this is the three graphs for a constant acceleration. Now, if the object moving with a constant acceleration, we have an equations to solve the problems. To solve the problems. What is this equations? We have V final or V equals V equal sorry Okay. V equals V naught, the initial velocity, plus AT. This is the first law. These equations called the equations of motion. This is the first equation. The second equation is x equals V naught t plus 1/2 AT squared. From these two equations, we can find a third important equation, which is V squared equals V naught squared plus 2AX. What is the importance of this equation? This equation has no time. It's a relation between V and X, the velocity and the position of the object. So we can use it if the time is not given in the problem. These three equations for a motion of constant acceleration. We use it only when the object moving with a constant acceleration. Okay, now let we take an example for this problem. Here, an example, a jet lands on an aircraft carrier with speed 60 meters per second. The technique to solve any problem in physics, first identify the known variables. The known variables, the first thing we have the speed, 60 meters per second, is the initial. This is the initial velocity, V naught. What is its acceleration? The second step is to identify what is we need. What is we need? We need here the acceleration. A is required to find. So the data we have V naught equal 60 meters per second, and he said that assumed constant, the acceleration assumed constant. If it stops in 2 seconds, the aeroplane stops, so the final velocity equals 0. V final equals 0, since the aeroplane is stopped in the end of the journey. Stopped in 2 seconds, so the time is known. Time equals 2 seconds. Okay, what is the required thing is acceleration. If we take the law V equals V naught plus AT, V naught plus AT. V, the final velocity, is known. V naught, initial velocity, also is known. T is known, 2 seconds. The only required thing is A. So we can find A from this equation. V, but the value of V is 0 equals V naught 60 plus A is unknown and T is 2. Transfer 60 to the left side with negative sign. So minus 60 equals 2A. Divide the two sides by 2. So we defined A equals minus 60 over 2, so minus 30. Minus 30 meters per second squared. A here is negative. Why? Why A is negative? Because the aeroplane is reducing its velocity. The velocity is reduced from 60, reduced up to 0, stops. So the acceleration is 0. We say that is deceleration. The second required in this problem, what is the distance it moved before stopped? We want to calculate the distance x. Okay, the law is x equals v naught multiplied to t plus 1/2 a t squared. T is known, A now is known. We find it in the first in the number A. V naught is known, time is known, so we have only x, so we can calculate it. So x equals V naught is 60 times the time is 2 plus 1/2 A. We find it minus 30 times t squared. T squared is 2 squared. So times 2 squared equals 60 times 2, 120 plus multiplied in negative equals negative 1/2 and 2 squared will be 4. 1/2 4 divided by 2 equals 2. So minus 30 times 2 minus 60. So the result will be 60. 120 minus 60 will be 60 meters. So this aeroplane will move 60 meters before it will be stopped. Thank you.